Okay, so this video is meant for my geometry students. We have a test on Wednesday covering Chapter 6, Sections 1 through 7. This is a 6.6 and 6.7 test review for you. Okay, here's problem 1. We're going to find x and y in this parallelogram. Okay, and if we take a look at this this problem here, since it's a parallelogram and these are all labeling the diagonals, we know that the diagonals of a parallelogram do bisect each other. So diagonals of a parallelogram bisect each other. So this is the idea we're going to use to solve this. Now, if I take a look, x is going to equal y plus 2. And that's an equation with two variables. I can't solve it. So I'll go to the other diagonal. Y plus 10 equals 2x minus 8. And again, that has two variables. I can't solve it either. But together, this creates a system of equations. And I'm going to solve this using substitution. And to use substitution, you need to make sure that one of these equations is solved for one of your variables. That means it says x equals or y equals. And that is true. Your first equation says x equals y plus 2. That step is done. It's solved for x. Now, we take this y plus 2, plug it in for x into the other equation. I'm going to do that right over here. So, y plus 10 equals 2 times what x is. X is y plus 2 minus 8. And now we'll solve this. Alright, I'll distribute the 2. Y plus 10 equals 2y plus 4 minus 8. I'll simplify over here. Y plus 10 equals 2y minus 4. Let's subtract y from both sides. I'm going to scroll down a little bit. That gives me 10 equals y minus 4, and then I'll add 4 to both sides. And y comes out to be 14. Okay? So there's my value of y, and now I'll take this value of y and plug it back into that equation to find x. X equals 14 plus 2. X equals 16. And here's the value of x and y that will then make those diagonals bisect each other. And that's how it goes. System of equations. Make sure you can solve one of these. And again, the first step, make one variable by itself, as was given in this problem. Okay, here's the second problem. This is a kite, and we're going to go through and find the measures of all the numbered angles. So angle 1, 2, 3, 4, and 5. Well, first, I know that in a kite, the diagonals are perpendicular. So right here, I'll use blue. This is a right angle, which makes angle 1, which makes the measure of angle 1 equal to 90 degrees, because it's also a right angle. Okay, and I think that's the only right angle up there. Okay, next, let's see. Well, if I want to find, let's find the measure of angle 4 using the triangle angle sum theorem, right? This is a right angle, that's 53 degrees. We'll use this triangle right here to find angle 4. So, triangle angle sum theorem says that the measure of angle 4 plus 90 plus 53 should add up to 180. That is the measure of angle 4 plus 143 equals 180. Let's subtract 143 from both sides. The measure of angle 4 is 37 degrees. Okay, and there's angle 4. 2 down, 3 to go. Next, let's find angle 2 in that exact same way. Angle 2 is also part of that this triangle, which has angle 1, which is a 90-degree angle, and this 38-degree angle. So we can use the triangle angle sum theorem again for the measure of angle 2 plus 90 plus 38 is 180. Add those together. The measure of angle 2 plus 128 is 180, and let's subtract 128. The measure of angle 2 is 52 degrees. Okay. And now to find the measure of angle 5 and angle 3, we're going to use this idea. In a kite, remember, there are opposite angles, and two things happen. Number one, if I have an angle between congruent sides, then the diagonal bisects me. So let's look at angle 3. Angle 3 is part of this angle right here, which is between these congruent sides. So this is congruent to that. They're bisected. So that means that the measure of angle 3 is 38 degrees. And similarly, angle 5 is part of that angle right there, which is also part of the large angle in between the congruent sides. So this angle is congruent to that angle. So again, this diagonal bisects this angle. So angle 5 is going to be 53 degrees. Okay. The other thing about kites is that the angle, the big angle, so this angle and this angle, formed by non-congruent sides, they are going to be congruent to each other. So these big angles would be congruent all the way across. All right? And that's everything you need to know about angles in a kite. Okay, next we're going to find the value of the variable in this isosceles trapezoid. Okay, it is important to recognize this is an isosceles trapezoid, and we know that in an isosceles trapezoid, the base angle pairs are congruent. So in this picture, I'll use blue. Angle T and angle W are congruent, and angle S and angle R are congruent. They are base angle pairs. The bases are TW and SR. So we can set, this is a 5x, we can set 5x equal to 60 to get our value of our variable. We divide by 5, x is 12. Okay, so this is 60, that'll make this 60. I think it's also important to talk about how we find T and W. If I wanted to find T and W, I need to know that the angles down the legs are supplementary. They are same side interior angles. So if I wanted to find angle T, so we'll use same side interior angles, which are supplementary. So if I want to find the measure of angle T, I'm going to add that to the measure of angle S, the 60 degrees, to get 180. And I'll subtract 60. So the measure of angle T is then 120, and that is always going to be the measure of angle W. So this is an isosceles trapezoid, 2 angle measures for all 4 angles, because the base angle pairs are congruent. Okay, question 4 here is a trapezoid mid-segment theorem question. Trapezoid mid-segment theorem. Okay? So in this picture, we know that CD is the mid-segment because of the congruent markings. That means that C and D are midpoints of the legs. That is what a mid-segment is. So by the trapezoid mid-segment theorem, CD is equal to half the sum of the bases, which are EF and HG. So I just plug in what I know. CD is 2x plus 4 equals half of EG is x, and HG is 4x plus 7. I will combine what's inside that parenthesis first. 2x plus 4 equals half 5x plus 7. And now, I don't want to distribute the 1/2. I want to get rid of the 1/2 by multiplying both sides by 2. Multiplying both sides by 2. Over here, parentheses are required. So when I distribute the 2, 4x plus 8 equals, on the right side, the 1/2 and the 2 cancel. That's why I did it. And I get 5x plus 7. Subtract 4x from both sides. 8 equals x plus 7. Sorry for bringing it down. Subtract 1. Subtract 7. 1 equals x. And that is exactly, I believe, what I had to find, the value of x. Oh, no, it wants the lengths of the segments. So there's x. Okay? So let's go back up to our picture. That's the value of x. Plug it in. That makes EF 1. CD is 2 times 1, which is 2, and 2 plus 4 is 6. And HG is 4 times 1, which is 4, plus 7 is 11. And again, notice CD, the midsegment, is right smack dab in the middle. It's 5 away from 1 and 5 away from 11. That should always happen with these midsegment, trapezoid midsegment problems. Okay, 2 more questions. Okay, here's number 5. We go back to a kite problem, and we're looking for the values of the variables. Okay, so all of the variables are in the angle measure. So let's take a look at what we can see. Okay, well, remember what we talked about before. Angles formed between the non-congruent sides are congruent. So I know that this angle is congruent to that angle. So I know that y equals 6x. But hey, that doesn't help me at all. Angles formed by the congruent sides are then bisected by the diagonal. So these 2 angles are congruent, and those 2 angles are congruent. Well, this right here is a 90-degree angle. So that makes each side 45 degrees. Well, now look at this triangle. 6x, 3x over 2, 45 degrees. Use the triangle angle sum theorem. 6x plus 3x over 2 plus 45 equals 180 degrees. And we can solve this for x, because everything involved is just x. Now, I do not like that 2 in the denominator, so I'm going to multiply this entire thing by 2 to get rid of it, which means I multiply the right side by 2. Everything gets multiplied by 2. 12x plus, now when I multiply the 3x over 2 by 2, the 2's cancel. 3x, 2 times 45 is 90, 2 times 180 is 360. Everything gets multiplied by 2. I'm going to combine the left side here and get 15x plus 90 equals 360. I'm going to subtract the 90 from both sides. 15x equals 270, and divide by 15. And I'll bring it over here, sorry. X equals, and we get, I believe, 18. Let me check my handy-dandy calculator. Yes, we do get 18. And there's the value of x. So then we just take that value of x and plug it in right up there. Y equals 6 times 18. Y equals 108. And there are your value of x and y in this kite problem. And again, all because we know whether the angles are congruent or whether the diagonal bisects the angles. Pay very close attention. Okay, lastly, I would like to do 2 of these problems. Sorry if I'm running long on time, but I want to take a look at these problems because there are going to be 3 of them on your test. Remember, we got to graph these and then see what kind of figure they are. So just a quick sketch, okay? This is not too big, so everything's just, within 5. So h is at -2, -3. I is at 4, 0. J is at 3, 2. And k is at -3, -1. And if I'm looking at this and I'm saying to myself, hey, I think it looks like a rectangle, but let's show why. Okay? So we got to find the slope. First, the slope of hi. Y's over x's. That's a minus a -2. That is plus plus. That's 3 over plus plus 6. And 3 over 6 is a half. Slope of, move on to ij. Y's over x's. 2 over -1. That's -2. Move on. Slope of jk. -1 minus 2 over -3 minus 3. That's -3 over -6. That's positive 1/2. Move on to hk. Y's over x is -1 minus -3 over -3 minus -2. That's a lot of negatives. Plus plus, that's 2 over plus plus -1, that's -2. And what do I see? Well, I see some parallel lines. HI is parallel to JK. IJ is parallel to HK. That means I am a parallelogram. Now, notice 1/2 and -2. They are opposite reciprocals. Angle I is right angle, which means you have 4 right angles, which means you are now a rectangle. Because you are a parallelogram and you have 4 right angles, you're now a rectangle. But there's one more thing to check. Let's check to make sure this is not a square. It could be a square. Alright? So we need to find 2 lengths, and I'll do them in a different color, light blue. We're going to find 2 consecutive lengths, and I'm going to do HI and JK. I'm going to write those down right here, because I have to scroll down. And again, if they come out to be the same, then I know this is a square. If they're different, then it's just a rectangle. So let's see. Oh, and I need IJ, and I need J as well. Sorry. Okay. So to find the distance from H to I, I'm going to use x's first. 4 minus -2 squared plus 0 minus -3 squared. That's inside a square root. 2 things at once. Plus plus, 4 plus 2 is 6, and 6 squared is 36. Plus plus, 0 plus 3 is 3, and 3 squared is 9. And this comes out to be the square root of 45. And now let's do IJ. X is first. 3 minus 4 squared plus 2 minus 0 squared. 3 minus 4 is -1, and -1 squared is +1. 2 minus 0 is 2, and 2 squared is 4. Square root of 5. They are not congruent. So not all 4 sides are congruent, meaning that this is a rectangle. Okay, last problem I like to do here. We are going to graph this quadrilateral again and see what kind of figure it is. Alright, so I see a -7 and a 6, so let's make sure we go out 7. And again, it's just a sketch. -3, 1, there's D. -7, -3, there's E. 6, 1, 2, 3, 4, 5, 6, -3. There's F, and 2, 1. There's G. And if I look at this figure, it looks like a trapezoid, but let's see. Let's make sure. Slopes. Slope of DE. -3 minus 1 over -7 minus -3. Y's over X's. This is -4 over plus plus. -4. That's a slope of 1. Move on to the slope of EF. -3 minus -3 over 6 minus -7. Plus plus, -3 plus 3 is 0. Plus plus 6 and 7 is 13. But when the numerator is 0, the fraction is 0. Slope of FG. 1 minus -3. Those are the Y's. 2 minus 6. Those are the X's. Plus plus, 1 plus 3 is 4. 2 minus 6 is -4. That's a -1. Last slope coming, DG. 1 minus 1, those are the Y's, over 2 minus -3. 1 minus 1 is 0. Plus plus in the bottom, 2 plus 3 is 5. But it doesn't matter, the top is 0, so the fraction is 0. And now I look at my slopes and I say, hey, I have one pair of parallel sides. EF is parallel to GG. Therefore, I am a trapezoid. But let's check to see if we are an isosceles trapezoid, right? Let's check the legs. That would be DE and GF. So I need to bring those numbers down. Okay, so I brought my numbers down, and again, I'm testing the legs, which are DE and GF. So let's test the distances, or the lengths of those legs. DE, X is first, -7 minus -3 squared, plus -3 minus 1 squared. Plus, plus, that is -4 squared, which is 16. This is -4 squared, which is 16, and there's square root of 32. Okay, so that's the length of DE. Now go to the other leg. The other leg is FG. X is first. 2 minus 6 squared plus 1 minus negative 3 squared. 2 minus 6 is negative 4 squared is 16. 1 plus 3 is 4. 4 squared is 16. That is the square root of 32. Hey, what does this mean? This means that the legs are congruent. DG or DE is congruent to FG. I am not just a trapezoid. I am an isosceles trapezoid. And there I go. Hopefully this video helped you, and you're ready to go on Wednesday or Thursday for my white day group. All right, have a great day, and we'll see you on test day.